Okay, inscribed angles, 10-4. What I want you to do is, do you see this little bit over here to the side? Yep. Put a circle. Draw a circle right here and this little bit to the side. I'll draw a better one. Okay, there's a little circle. All right, and I'm going to draw a chord, and I'm going to draw one that looks like this. Boop. Do them like that. Okay, that's a chord, right? Do we know that that's a chord? Chord goes from one edge of the circle to the other, okay? The chord that goes through the center of the circle is called the diameter. Okay, great. Now, here's what I'm going to do. I'm going to pretend that that's a little string, and I'm going to pull him back to the center, right? So let's say I take this little string and I pull it back here, right? Okay? And let's say that this arc, the measure of that arc was 110 degrees. What is the measure of this angle right here? 110 degrees. Does that make sense? The arc is 110. The central angle, this is called a central angle because it's in the center. It pulls back, it is 110. Now, here's my question.
Oh, like the protractor.
Let's say instead I start here and I take that string and I pull it back way, 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 way far, all the way across the edge of the circle. Is this still 110 degrees?
Yeah. No.
That's an acute angle. What is it now?
13.
No.
It is half of it. It is 55 degrees. Okay? Now, what happens instead, I'm going to take those same points and I'm going to pull them over here. Let's say I pull them right here instead. Right? I'm pulling him back this direction. How big is that angle?
A third.
Still 55 degrees. Let's say I pull him over here. Whoop. Right there. How big is that angle? 55 degrees, right? If I pull him back to the center, you see this? If I pull him back to the center, he's the same measure as what he was before, right? But if I pull him all the way across the circle, it doesn't matter where I pull him. Here, here, here. If he's all the way across the other edge of the circle, he is half, right? Half the measure, right? Got it? Does that make sense? Okay, let's go to these pictures. So this is the same thing right here. Case 1, case 2, case 3. Shh, listen. This guy, let's say this guy was, 140 degrees. And I pull him back. Let's say I pull him back just to here. What's that central angle right here? 140. But if I pull him all the way across to the other end of the circle, what's this angle? 70 degrees, right? If I pull him all the way across, okay? All right. How big does this angle look?
4.
Let's do that.
4 degrees.
That looks bigger than 40.
100.
90 degrees is like a full corner right here. How big is that angle?
45.
75.
I'm going to say, let's say 80. Sure, whatever, 80. So how big is this arc?
80.
160.
160. It's double, right?
Oh, yeah.
Yeah, all the way across the circle is double, right? Okay, let's go over here. How big does this angle look?
14.
25.
25? I'll buy 25. Okay, so how big is this arc? 50. Okay, if it's across the circle, it's double. If it's only back to the center, it's the same. Got it? Yeah? Okay. All right, let's do a couple more things. Okay, let's look down here at this little diagram. Okay, you see how there's like little ice cream cones going on? Okay, I'm going to show you the first ice cream cone. You see this little ice cream cone right here? You see my pink ice cream cone? Yeah? Let's say that this angle right here was 60 degrees. Okay, and this is the top of my ice cream cone. How many degrees is that? 120. Okay, now let's say I pull him back in a different spot. What's the measure of this ice cream cone? 60. So here's the rule. Are you ready? They are the same cone that has the same ice cream, right? Like two different cones that have the same ice cream. Correct? They have the same ice cream on two different cones. Those cones are the same measure. Does that make sense? So if they share the same arc and they're pulled back just in different spots, they're going to be the same measure. Got it? Does that make sense? Okay? All right, let's do some problems. Here we go. Example 1. Use inscribed angles to find the measure. All right, here we go. They want to know the measure of arc CF. Do you see where CF is? They want to know how big this angle is, or this arc is. Okay, this is 40. That's what the 40 was measuring. So this guy has to be 80 degrees. That's part A. 80 degrees. It's double what that is, right? Then they want to know what the measure of angle C is. What's the measure of this angle right here?
8.
Half of
40.
98.
Oh, 98 is right here. Do you see this?
I don't.
Okay, 98 is there. Here's my ice cream cone.
49.
Half of 98 is 49 degrees.
Why couldn't they just let me 50?
I don't know. So this is not a 90-degree angle right here. True? It is a 91 degree angle. Yeah? That is 91 degrees. That's interesting. Okay? So, 49 degrees is what angle C is. Do we see how that works? Okay? Just half of what the arc is. Got it? If it's all the way across. Okay? All right. Here we go. They want us to find the measure of angle A. I'm going to look at angle A. Angle A is this one labeled with the 5x minus 12. You got him? Okay, I'm going to look at his two lines, okay? Now, take a look at him. What arc makes up angle A? BC. But take a look at this one.
They're the same.
Those two are going to be the same. So what do I do?
It's gotta be equal to each other.
5x minus 12 equals 3x plus 2. Yeah? Okay, so I'm going to subtract 3x. 2x, if I add the 12 over, is 14. X is 7. Okay, but they want the measure of angle A, right? So I'm going to plug 7 back in. 7 times 5 is 35. What's 35 minus 12? 23. I heard Dylan say that a long time ago. Awesome. Okay? Good, good? Okay? So you're kind of looking at ice cream cones on how they fit, right? Okay, but if it's across the circle, it's double. All right, example 3, skip. Go to one more couple really important things. Ready? This little diagram right here. Go to where it says inscribed polygons. This is super, 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 super important. Are you ready? They're going to get you on this one. Let's look at angle G. All right? FH is what? What is this thing called? Is a diameter. Okay, but take a look at this. This is an arc right here, and how big is that arc? How many?
180.
180. So what's the measure of angle G? 90. So 90, not 70, 90, right? Okay, so here's the kicker. Okay, this is the shortcut. If you have a triangle that is inside of a circle and one of the edges of the triangle is the diameter, this angle will always be 90, right? Let me show you another picture. Let's say I have the diameter here and I pull him back this direction. This angle is 90. Let's say I pull him back over here. This angle is 90. Let's say I pull him back. Have you guys done this with string before in elementary school? Will you take him and pull him back? Okay. All of those triangles have a 90-degree angle in them. They all look a little bit different, but the reason why it's 90 is because this is the diameter and this is 180. And that's half of that, right? If you keep pulling it back, right? So 90 degrees. So if you have a triangle that's inside of a circle that goes through the diameter, it is 90 degrees. Okay? All right. Last kind of little thing, and then we'll do a couple of examples. We'll be done. Okay? If a polygon, so let's say you have a four-sided figure that's inside of a circle, right? It says that L and N are supplementary. These two that are across from each other, are they the same measure? No. But if L is, let's say, 80 degrees, then N is 100. They're supplementary, right? They add up to be 180. The ones across from each other add up to be 180. That's how that works. Okay? Let's say M is 60. What's K? 120. The ones across from each other add up to be 180. Got it? Okay, let's do an example. Example 4. We've got this guy right here. Find angle measures. All right. This is interesting. KM is the diameter. So if that's the diameter, then what do I know about angle L? Is 90, okay? What else do I know?
You know that those two together make 90.
These two add up to be the other 90, right? So they're not equal to each other, right? 5x minus 4. If I add that to the 8x minus 10, that equals how much? 90, right? Because this is 90, this guy's 90, these add up to be the other 90, right? Okay? Okay, so 5x and 8x is 13x minus 14 equals 90, right? 13x equals 104. Does that divide nicely? I don't know. 8? Yeah, 8. X is 8. But they want to know what is? If I'm finding the measure of angle K. So I got to plug in here. 8.
36.
5 times 8 is 40, minus 4 is 36. You betcha. Okay? Got it? All right. But the kicker there was knowing that this is a 90-degree angle, right? And the other two add up to be the other 90. Let's go to 5. Oh, boy. Oh, boy. Okay. We've got this looks like a trapezoid, but it's not because the two sides are not parallel. But it is a four-sided figure. What do we know about four-sided figures? The opposite ones are Supplementary, not equal. Not equal. The opposite ones are supplementary. So these two add up to be 180 and these two add up to be 180, right? Which is nice because the x's and y's are opposite each other, okay? So let's do the x's first. So if we do these two, those two add up to be 180. 3x minus 16 plus x minus 4 equals how much? 180. 4x minus 20 equals 180. 4x equals 200, and x is 50. Okay, we're supposed to find x and y? Nope, not yet. Okay, let's do the other one. These two have to add up to be how much?
I don't know.
180.
And there's a little
180. What's at the bottom? Oh, he says he's going to shut off, but he's not. Okay, how many y's? 8y plus 20 equals 180. 8y equals how much? 160, and that is 20. So x is 50 and y is 20, and they want us to solve for f and g. Okay, f is this guy, and I'm going to plug 20 in here. 3 times 20 is 60 plus 4. 64 is f, and g is 50 minus 4, so 46 degrees. Okay? The ones across from each other are supplementary. Got it? That's it. Hey, look at that. Okay, so for I explained this before I started doing the lesson, but here's what I mean by right column. So 2 through 10 evens, 2, 4, 6, 8, 10, right? And then on the back page where it says right column, here's what right column means. 15, 16, 19, 20, and 23, 24. I did that rather than having you do the evens because, like, you have to be able to do 15 in order to do 16. So you'd end up doing all the problems anyway. So just the right column there and then evens on the bottom. So 26, 28, 30. For those of you who are watching the video, right column there, evens on the bottom, and then evens on the front side except for 12. So 2 through 10 evens. So there's that. Okay? All right, that was really fast. Do you guys have questions? Okay, do you have a question before I stop the video, Dylan? Or not?
Oh, yeah, no, I
They share the same ice cream cone.
Yeah, the ice cream cones, if they share, they're the same. Okay? All right, there you go.